evaluate the integral from 0 to pi over 4, the fifth power on tangent times the fourth power on secant. Now, secant has an even power and tangent has an odd power. Let's attack it. We have either way to attack it. Let's attack it as the power on tangent is odd. And if that's the case, then we need to factor out one power of secant and one power of tangent. That'll set up the U substitution for us. It'll still leave us with 4 powers of tangent and 3 powers of secant. But we have factored out the secant tangent so that we can do a U substitution. The function that has secant tangent as its derivative is secant of x. So these secant cubes will stay, but these 4 powers of tangent need to be transformed into powers of secant so that we can set up our U substitution. So the identity that helps you do that is that the tan squared on x is equal to the secant squared on x minus 1. We have tan squared squared. We replace the tan squared with secant squared minus 1, and we're ready to set up our U substitution. If we let U equal secant x, then this will be some polynomial in U times U cubed, and then the derivative is conveniently here. If U is secant x, then du is secant x tan x. This guy will end up as U squared minus 1 quantity squared, and then we'll have U cubed on the outside to multiply that. And we'll do the integral indefinitely, and then go back in terms of x and plug in the 0 and the pi over 4. Okay, great. Multiplying out U squared minus 1, what we get is U to the fourth minus 2 of the U squared plus 1. And then on the next slide, what we'll do is distribute the U cubed across. Let's go to that. So multiply it out. Now distribute the U cubed across. And what we have is U to the 7th minus 2U to the 5th plus U cubed. Okay. Antiderivative, power rule in reverse, U to the 8th over 8 minus 2U to the 6th over 6th plus U to the 4th over 4. This 2 can turn the 6 into a 3. We'll go ahead and plug back in for U, replace U by secant x, and we're looking at an eighth of secant x raised to the 8th, a third, subtract a third of secant x to the 6th, and add on a fourth of secant x to the 4th. And we'll plug in a pi over 4, and we'll plug in a 0. Now the secant on pi over 4 is root 2. We get that by saying that it is 1 over the cosine on pi over 4. And that's root 2 over 2. In the denominator, the reciprocal of that is 2 over root 2. Rationalizing top and bottom by root 2, we get 2 root 2 all over 2, and that's how we end up with our root 2. So the secant on pi over 4 is basically just going to be a root 2. But don't forget though, the secant on 0 isn't 0. The secant on 0 is going to be 1. It's going to be reciprocal of the cosine of 0. And that's just a 1. Okay, great. So we get root 2's the first time through, and then 1's the second time through. And we have to raise these guys to powers. Well, the 1s to powers won't be a problem, but the root 2s to power might end up as a slight problem. Let's go to the next slide for that and figure out how we raise root 2 to the 8th and root 2 to the 6th and root 2 to the 4th. So it turns out that root 2 to the 8th will be 2 to the 4th. Think about it. It's since root 2 is 2 to the half, when we go to raise it to the 8th, we'll have 2 to the half and to the 8th. You can multiply the exponents and you'll end up with 2 to the 4th. Similarly, 2 to the 3rd when we have root 2 to the 6th, and 2 squared when we have root 2 to the 4th. So we're going to replace these guys and put them over the denominator that they go with. 2 to the 4th goes over the 8, the 2 to the 3 goes over the 3, and the 2 to the 2 goes over the 4. Okay, well 2 to the 2 is 4. 4 over 4 is just a 1. This doesn't go away, it's a 1. And then 2 to the 4 is 16. 16 over 8 is a 2. This guy's just 8/3. On this side here, we'll have an 1/8 and a 4th. We can put those together as both being 8ths, 2/8 and 1/8. That's how we get that 3/8. And then we have our 2. We have our 1. Take away the 8/3 minus the 3/8 by putting these two guys together. And then take away the 1/3. Let's distribute this across and then write it out. 3 by putting the 2 and the 1 together, minus 8/3, then plus a 1/3 because it's double negative here, and then minus 3/8. These two guys go together to give you 7/3. So 3 minus 7/3 minus 3/8. Common denominator would be 24. So we times by 24 for the first fraction. We times by 8 for the second fraction. We multiply by 3 for the third fraction. 24 times 3 is 72. 72 of them minus 56 of them minus 9 of them. 56 and 9 is 65. 72, take away 65, leaves you with 7 of them. Final answer, 7/24.